And welcome to lesson 8.1, day 1. Today we are going to talk about the converse of the Pythagorean theorem. Now, we've talked a lot this year about Pythagorean theorem, and we know that it is found by taking a squared plus b squared equals c squared, or the reverse. A and b are your two legs of your right triangle. The c is the important side. That is the biggest side, and that will always be across from your right angle. A and b are kind of interchangeable, because you just need to associate that with each leg. C is the important one. It is always the hypotenuse. Sometimes we have used Pythagorean theorem to solve for the hypotenuse, where a squared plus b squared equals c squared, square root to find that final side. Sometimes we have used subtraction to help us find a missing leg by taking c squared and subtracting away either a squared or b squared, and again square rooting to find our final answer. Okay. Today we are going to talk about using the converse of the Pythagorean theorem to find what type of triangle we are given, whether it is right or not. We also can use Pythagorean theorem in some word problems. So in these first examples, we are looking to determine if something is a right triangle. And this is going to work if we can make a squared plus b squared equals c squared. Okay, we're trying to see, does this work? So again, the important piece here is that the side across from your potential right angle, in this case, we don't know that for sure, aka the biggest side, has to be our c squared each time. So in this case, 97 has to be c. Our a and our b are just the two smaller sides, so 65 squared plus 72 squared. And again, we're just checking out, does 97 squared equal what 65 squared plus 72 squared equals? The answer in this case is yes. They both equal 9,409. So because of this fact, we would say yes. In our next example, the biggest side out of these three is 23. So that would have to be the potential C. And then we would check out, does this equal the two smaller sides, 20.8 and 10.5 squared? Okay, again, we got to check, does this work? So does 23 squared equal 10.5 squared plus 20.8 squared? This time the answer is no. 529 does not equal 542.89. So this one would be no, that's not a right triangle. Last but not least, we want to test out, again, our potential hypotenuse this time is the square root of 26, which is a little over 5. And then 1 and 5 would be our smaller sides. Now, anytime you square a square root, we notice that that undoes the square root. So this just becomes 26. And then 1 squared plus 20 or 5 squared is 26 as well. So in this case, it did work out. So this is again a yes. All right, try the final example on this page yourself. Is this a right triangle? Yes or no? On the back, we have a word problem to use Pythagorean theorem in a little bit of context. So it says, how high up a vertical wall will a 24-foot ladder reach if the foot of the ladder is placed 10 feet from the wall? We're rounding to the nearest 10. So think about a ladder. When you lean it against a wall, your ladder is leaning. And this time our ladder is 24 feet tall, and it's being placed 10 feet from the base. Now we're going to assume our wall, again, is a vertical wall that's making a nice 90-degree angle, and we are going to solve for that height of the wall. So again, we're going to take 24, aka this ladder is going to act as our hypotenuse. So 24 squared has to equal then our missing height plus our base squared. So again, this time we need to make sure we subtract over the 10 squared to get x squared by itself. So 24 squared minus 10 squared is 476. Now that again is our x squared value. And this time we are just going to round to the nearest tenth. So we can just square root that answer. And we get about 21.8 as the height of our wall. All right, last but not least, beyond testing our triangles, if it is right, we also can potentially test for two other things. Number one, is it even a triangle? So we need to make sure that the sides, the two smallest sides, have to end up being greater than the sum of them has to end up being greater than the third side. And again, greater, not or equal to. And then if that stands true, it is a triangle. And what we then are able to tell is specifically what kind. Now, we already talked about if these are equal, we would have a right triangle. But if c squared is less than a squared plus b squared, it could be classified as an acute triangle. So again, all those angles are smaller than 90 degrees. If c squared is greater than a squared plus b squared, it would be an obtuse triangle. And again, that means that one of those angles, particularly the one across from C, is going to be bigger than 90 degrees. Okay, so we have some examples here below. Now, first and foremost, if they are giving you these out of order, always look for the largest side. In this case, that side C would have to be 6 because that's the biggest. Remember, if this is going to be your hypotenuse, that would have to be the biggest side. And again, we need to start off by checking, are A and B, when we add them together, bigger than 6? Because what's happening is if part 1 isn't true, that A and B are bigger than C when added together, then we just stop. So in this first example, 5 is not greater than 6. Okay, so what's going to happen is this is too small, these side lengths, to even be a triangle. So we would stop there and say this is not a triangle. In our second example, 37 would have to be our C value because that's the biggest side, and we want to check, do our two smaller sides sum to be bigger than that third side? This time the answer is yes, so we can move on to step 2, actually testing out how does a squared plus b squared compare to that c squared value. Okay, so in this case, we have a squared and b squared are 12 squared plus 34 squared. Again, our two smaller sides. How does that compare to the biggest side, 37? Well, the 37 squared is bigger, right? This is bigger. This is 1369. And then a squared plus b squared was only 1300. So if your c squared is the biggest, this triangle ends up being obtuse. Another example, okay, notice on this next one, all three of these actually have the same denominator. They all have 7. So what we're going to do is we can kind of ignore this fact because they all have the same denominator. We can just focus on the numerators. And in this case, our c would have to be 10. Now 6 plus 8 is 14. That's greater than 10. So this is a triangle. So we can move on to step 2, which is testing out, is this bigger? Okay, a squared, or test out what is happening here. 6 squared plus 8 squared. How does that compare to 10 squared? Well, in this case, they are equal to each other. Both of them equal 100. So because they are equal, like we talked about on the first page, this has to be a right triangle. Last but not least, we want to check out, again, A, B, and C, which is the biggest. Now, in case we were wondering, square root of 42 is only about 6.5. So that's actually our smallest side. This time that means C would be our biggest side. And if we add 20 plus square root of 42, which is again about 6.5, that is going to be bigger than our C side. So this is a triangle. And then if we test this out, 20 squared plus the square root of 42 squared, how does that compare to 21 squared? Well, 20 squared plus the square root of 42 squared is 442. 21 squared is 441. So because the a squared plus b squared is bigger than our c squared, this time this would be an acute triangle. I like to think when you're going towards a squared being bigger than the c squared, it has to go towards acute because they both start with a. We have 3 final examples for you to try out. Again, start testing out what kind of triangle it is, if it is even a triangle, and then is it acute, right, or obtuse for A, B, and C. Thanks everyone for watching. We'll work more in class.